Quick question. How many sales calls does your QA team actually review? 1%? 2%? Now imagine the other 98% contains phrases like guaranteed returns, no lock-in, withdraw anytime. That's how mis-selling happens. Today we are building MisSell Guardian, an enterprise-style agent that reads sales conversation, detects mis-selling risk, checks mandatory disclosures, generates coaching, and creates audit-ready evidence using anti-gravity with LangGraph plus React. This is not just a cool AI demo. This is a real business pain. Mis-selling leads to penalties, customer complaints, refund storms, and brand damage. MisSell Guardian flips the model from reactive audits to proactive guardrails. Analyze 100% of conversations, escalate only risky ones, coach frontline teams so quality improves, and keep a clean audit trail for compliance. Let's take a look at the architecture behind this system. At the front, React provides a clean business-friendly user interface. This is where compliance teams, quality analysts, and sales managers interact with the system without needing to understand any AI complexity. Behind the scenes, FastAPI acts as a backend gateway. It validates inputs, exposes secure APIs, and orchestrates requests between the user interface and the intelligence layer. At the core of everything sits LangGraph, which runs the agentic workflow step by step. Instead of a single black box prompt, the problem is broken down into clear stages: ingestion, interpretation, validation, scoring, coaching, and audit. And this design follows two very important principles. First, large language models are used only where they add the most value. Understanding human language, detecting risky phrases, identifying missing disclosures, and generating clear human readable summaries. Second, all risk scoring and decision logic is handled by deterministic code. This ensures consistency, repeatability, and trust. So, leadership, auditors, and regulators can understand exactly why a decision was made. This separation is what makes the system both intelligent and enterprise ready. Now here is the real secret behind making agents works in real world: context engineering. Most people take sales transcript, drop it into an LLM and hope for the best. Sometimes it works, most of the time it doesn't. And that approach might be fine for demos, but it completely breaks down at enterprise scale. Context engineering means we don't rely on hope. We give the model a context pack, a structured, repeatable source of truth that tells the model how to think. That context pack includes clear product taxonomy, so the agent knows whether it's dealing with a credit card, a loan, a ULIP, or a health policy. It includes mandatory disclosures per product, so the model can explicitly check what must be said, not what sounds good. It includes forbidden phrases, the exact promises that should never appear in compliant sales conversations. And most importantly, it includes strict output schema, so every response is structured, explainable, and auditable. This is how the agent stops behave like a chatbot and starts behaving like a system. The result is consistent decision, clear expectations, and output that leadership and regulators can actually trust, not random advice generated on the fly. I am going to show the exact developer prompt that powers this entire build. This is not a simplified example and it's not slide version. This is the real prompt I use inside Anti-Gravity to generate the full system: backend, frontend, workflow, and context pack. Take a moment here, pause the video, read it carefully, and copy it. If you follow this prompt step by step, you can reproduce this entire agent on your own. The LangGraph workflow, the Fast API backend, the React dashboard, and even the compliance logic. This is the part of the video where implementation starts, not theory. So pause here and let's build. Now let's build. This is where theory turns into a real working system. Inside Anti-Gravity, we start by scaffolding the foundation, a clean intentional monorepo. We separate concerns right from the beginning: a backend for intelligence and orchestration, and a front end for business users. On the backend side, we lay out everything an agentic system needs to stay maintainable at scale: the LangGraph workflow, a clearly defined graph state, individual nodes, prompt templates, rule catalogs, API routes, and space for tests. At the same time, we set up the Python virtual environment, install dependencies, and wire Fast API as the gateway. This ensures every request is validated, traceable, and production ready. On the front end, we generate React White application. This becomes the business friendly layer where compliance team, QA analyst, and a managers interact with the agent without ever touching code. Once the structure is in place, we move to the heart of the system, the workflow itself. We define each node explicitly: an ingestion node to normalize conversations, a product mapping node to understand what's being sold, a rule lookup node driven by our context pack, a compliance analysis node where the LLM interprets language, a deterministic scoring node that leadership can trust, a coaching node that improves frontline behavior, and finally an audit node that records everything. This step by step structure is what turns an AI idea into an enterprise agent, predictable, explainable, and ready to scale. Now, here is the part I always show because this is what real development actually looks like. Everything was going smoothly, and then we hit a very familiar wall. When we ran the command npx tailwind css init -p, the terminal immediately threw an error. Npm error could not determine executable to run. This is one of those moments where many tutorials conveniently cut the video. But in real projects, especially enterprise build, this happens all the time. So instead of panicking or randomly searching, we step back and applied the same principle we use for AI systems. We tighten the context. We told the tooling exactly what we wanted it to run. First, by forcing the package execution, npx package, tailwind css init p, and alternatively by calling the binary directly from node modules. Node modules being tailwind css init p. Once the context was explicit, the package, the path, the executable, the error disappeared. And this is actually a perfect parallel to context engineering. When tooling fails, just like when LLM fail, the problem is rarely intelligence. The problem is ambiguity. You don't panic, you don't guess, you make the context tighter, clearer, and more explicit. Whether you are dealing with the build tools or AI agents, the principle is the same. Clarity beats cleverness every single time. The next issue we hit is a great example of why enterprise builds are never static. Tailwind CSS version 4 changed how post CSS plugin work. And the moment we ran the app, White warned us. The Tailwind post CSS plugin has moved to a separate package. This kind of message looks small, but it represents a bigger reality. Tooling ecosystems evolve constantly. What worked 6 months ago can quietly break today. The fix itself was straightforward. We installed the new package Tailwind CSS slash post CSS and updated the post CSS configurations to explicitly reference it. But the real lesson isn't the command. The real lesson is mindset. The enterprise systems, your job isn't just to fix the error in front of you. Your job is to capture the fix as reusable knowledge. You document it, you standardize it, and you make sure the next build doesn't hit the same wall. This is how teams move faster over time, not by avoiding errors, but by systematically learning from them. And here is the bug that looks scary but is actually simple. The app didn't load and we got the requested module src type.ts does not provide an export name conversation analysis result. Build MisSellGuardianAgent. This happens when TypeScript interfaces are treated like runtime values. The fix is clean. Use import type. So in API.ts, the pages we switch to import type conversation analysis result from dot slash types. Now the UI loads reliably. Now comes the fun part, the demo. We paste in a real world mis-selling style TypeScript, phrases like guaranteed returns, no lock-in, and withdraw anytime. Exactly the kind of language that creates problems later. As soon as we hit analyze, the agent takes over. It automatically detects the product if it's not explicitly mentioned. In this case, it correctly identifies a ULIP. It then loads the ULIP specific rules from the context pack, checks which mandatory disclosure were communicated, and flags risky promises that violate compliance expectations. Next, the system assigns a clear explainable risk score, not a black box decision, and generates two separate outputs. The first is a compliance summary for QA and audit teams, factual, neutral, and evidence based. The second is a coaching summary for the salesperson, constructive, supportive, and focused on what to do better next time. And this is how you drive real adoption. The system doesn't punish, it improves behavior, it helps teams sell better, stay compliant, and build trust using real conversation history as a feedback. If this breakdown of the context engineer MisSellGuardianAgent was helpful, take a moment to hit the like button. It really helps this video reach more builders like you. If you know someone working in banking, insurance or compliance, share this video with them. And this is a problem lot of teams are trying to solve right now. And if you want the full prompt pack, the rules catalog template and the exact error fix checklist we use today, drop a comment with MisSell. I'll share it. Make sure you subscribe to AICKStudio and turn on notification. This channel is about building real enterprise grade AI, not just demos. I'll see you in the next one.